Okay, next question. Looks like a distribution, normal distribution. The farmer grows two types of apple, cooking apple and eating apple. The weight of the apple in grams can be modeled as it says normal distribution here. Follow this parameter. So eating apple is mean is 100 gram and standard deviation is 20 gram. For cooking apple, mean is 140 and standard deviation is 40. Each type of apple can be measured. Each type of apple can be measured 95% of the weight are within the two standard deviation of the mean. Find the percentage of eating apple that have weight greater than 140 gram. Okay, let's draw a graph. So eating apple. So eating apple weight is follows normal distribution. So mean is 100 gram and standard deviation is 20 gram. So here is minus 20. Here is plus 20. I'm writing minus 20 plus 20 actually, but 100 minus 20. This value is 80. This value is 120. I'm making this a little bit simpler. Okay, so cooking apple there. Find the percent of eating apple that have weight greater than 140. So it says 95% of the weight are within two standard deviation of the mean. Two standard deviation. This is one standard deviation over here. Two standard deviation is plus 40 here. So this value is gonna be 140. This is 80. This is 60 here. So 90% is located within two standard deviations. So which means that this is from the mean one standard deviation and two standard deviation. Here value over here is 90%, so 0.95 is located over here, which means that this portion here, this portion here, here, and here is only 5% each. So this is 0.025. This is also 0.025. Adding these two numbers is 0.05. Okay. Find the percentage of eating apple that have weight greater than 140. Greater than 140 is here, greater than this sector. So greater than this sector is gonna be 0.025. So answer is probability. Okay. Probability x is greater than 140 equals 0.025. The farmer grows a large number of apples, which 80% are eating apple. 80% are eating apples. Both types of apples are picked and randomly mixed together, and the cleaning machine. After cleaning, the machine separates out those that have weight greater than 140 gram into the container. The apple is randomly selected from this container. This is randomly selected. Find the probability that it is an eating apple. Okay. So what we can do is we can draw a probability diagram. So first clue here we have 80% are eating apple. So and then mix together cleaning machine. After that is weight greater than 140 is put into container randomly and then randomly selected. So initially the apple can be either eating apple or cooking apple. Eating apple is 80%, so probability eating apple is 0.8, probability cooking is 0.2. And then for eating apple, the probability that weight is greater than 140 more is how much? 0.025. 0.025, which means the probability weight is less than 140 is 0.975. for cooking apple, probability greater than 140 greater or 140 less. So if you see the cooking apple here, is the mean is mu and standard deviation is 40, which means that for cooking apple, normal distribution mean is already 140 gram. So there's chance of this side is already 0.5, the other side is already 0.5. So for cooking apple, the probability of greater than 140 is 0.5, and less than 140 is also 0.5. So after this container and the weight greater than 140 is put into container, so which means that we can calculate the probability. So more than 140 only happens over here and here. The probability of here eating apple more than 140 is 0.8 times 0.025, and probability of this event happens is 0.2 times 0.5. Find the probability that an eating apple, that is an eating apple, so over here. So apple is randomly selected from this container. So in this container, there are probability this one is. So among this one, find the probability of this one. So all we can do is adding these two numbers, 0.8 times 0.025 plus 0.2 times 0.5. Among this is the bottom line, what is given, and then find the probability that is an eating apple, which is 0.8 times 0.025. We have to calculate this. Multiplying 1000, no, multiplying 10,000 each on the numerator and denominator will give us, we can use 10 over here, we can use 1000 over here, so 8 times 25, this becomes 20 times 50, so this is times 8 times 25. So this is 8 times 25 is 200. 8 times 25 is 200 plus this is 1000. So 200 over 1000, 200. So this cancels out, so 1 over 6.